Hi, I'm Raymond from ASC, and in this video I want to talk about some of the ways you can troubleshoot your SlumberTek if you're having issues with accuracy. This is going to be a video specifically about the firmware version, which is called 0.3.0. I might make some updates in the future to some names and UI elements, but a lot of the information in here is going to still be very relevant. The first part that I'm going to go through, you do not have to watch the whole thing. I would 100% suggest jumping to the chapter selection underneath, going to your specific problem if you have one. Otherwise, you can just watch it to understand more about how SlumberTek works. I'm going to talk about some general tips on how to get better signal. I'm going to talk about how the algorithm works if you're interested. And then I'm going to get into all those situations where you might have a problem or a specific problem and you want to know how to solve it. Okay. On to the first section then. Let's talk about ways that you can increase your signal quality generally, because the better signal that you get from your SlumberTek, the better chances you're going to have high accuracy. We're trying to get to that 100% accuracy where it just works all the time, every day. So if you have a stiff mattress and a box spring underneath it, I found that this is actually the best combination so far for signal. If you have that combination, then your signal is as good as it's going to get. And really this image here is just to remind you to make sure you put your SlumberTek horizontally, so side to side, and not vertically, because if you roll off of your SlumberTek in the middle of the night, then it's going to think that you've gotten out of bed, even if you rolled maybe closer to the middle of the bed. So if you have a box spring, that's great. A lot of people have slats. And one of the things that I've noticed about slats is because there's that big gap in between, and everybody's slats are a little bit different, and several people have very high accuracy even with a slat bed, but sometimes slats can have a very big gap between them, and they can be quite thin. And this whole gap in between here, because of this pressure sensor area, isn't being used at all, and there's no signal coming out of that. So nowadays, I highly suggest people, if they have slats of any kind, to use either the packaging, the cardboard packaging that came with your SlumberTek, or a piece of plastic, or a piece of thin plywood or something, and put that underneath and really create a big, large, flat surface underneath your SlumberTek. That's going to improve your signal, and again, that's going to improve your accuracy. There's two other things I want to say about too, which is if you have a soft bed and slats, which is so far I've seen kind of that's the combination that has the least amount of signal out of the device. And not only does it have low signal, but you can actually, if your slat is here and your SlumberTek is on top of it, a soft bed will droop underneath your slats and actually push against the edge of your slat and your SlumberTek and actually possibly damage it. I am always looking for ways to improve SlumberTek, and this is definitely one of them. I got to figure out a way to make it a little bit stiffer while still being kind of like rollable and flexible. So that way, slat beds, you can just take your device, slide it underneath, and it just works fine. Now, the other thing I will say here is a lot of people have flat flats, which is easy to work with when you want to put a flat surface top of it. It is less easy to put a piece of plywood if you have curved up slats kind of thing, because that's going to be, you're going to be sitting on top of a curved surface. So in that case, I wouldn't use plywood. You might be able to get away with some thin plastic, but again, cardboard, you can still use something that is going to kind of conform to that shape, because again, all we need to do is we're trying to increase the surface area and just put something underneath this gap so there's more signal comes out of your SlumberTek. Okay, let's go on to the next section. This section is about the algorithm that runs your SlumberTek. You do not need to watch this section. This is solely if you're interested in learning a bit more about how the device actually works. If you are just here to do your troubleshooting, skip this section, jump forward to one of the specific questions that you have in the chapters, because this isn't that necessary to understand. If you're more than welcome to watch this and then understand a bit more about why we're changing certain settings to solve certain problems later in the video. So let's talk about the algorithm. And to talk about the algorithm, I like to visualize it a lot more. So what I am doing on the left side of the screen here is this is just the Home Assistant history. I've pulled out a bunch of elements that are kind of the most relevant ones that we're going to talk about. They're just from this device, which is called O24 testing. And I've pulled out the calibration switch. I've pulled out the bed sensor, binary, and all the elements down here are what we are going to talk about. So, although I probably should move my head so you can see them, and also this chair. Okay, so the first one we're going to talk about, and the most important one we're going to talk about, is called the pressure voltage. And this is the voltage that is related to how much pressure you have on your device. So if I press down, so I have a device in front of me on the floor. If I press down on it, then the voltage is going to go down. I'll hold it for a second. And then when I take my foot off of it, the voltage is going to go back up again. All the decisions about whether or not you're in and out of bed from your SlumberTek are made from this element, this pressure voltage entity. Okay, let's talk about the next elements of the algorithm. Let's talk about the full bed value and also the empty bed value. So if I put both my feet on my device here, I'm going to go below the full bed value, this yellow line, and I'm going to trigger to a detected state. Now, there is actually I'm going to go over here and go into the dots and then device info, because I can read these full names now. There is a transition. The amount of time that the pressure voltage needs to be below this full bed value before it triggers to be detected. That is what this transition to on delay is. You can move it all the way up to 10 seconds. You'd only want to move it up if you wanted to really make sure that you were below and this line, and so you just had more confidence that you were definitely in bed and it wasn't some sort of weird spiking. Same thing actually for the transition to off delay, which is now if you go above the empty bed threshold, and you can go all the way up to 20 seconds on that one. So in order to make sure, again, that there isn't a unexpected spike in data, and you don't want it to quickly transition, some sort of trigger to an automation very quickly. So I'm actually going to take one foot off here, and hopefully, I'll be right in between. And I have gone above this full bed line, but I have not gone above this empty bed threshold here, or this empty bed value. And so I'm still detected as in bed. And then when I raise my other foot off, I will go above this empty bed threshold, and now I will trigger to clear. And again, that was relatively quick because it only needs 1 second of data over the empty bed threshold before it is triggered to clear. Okay, let's talk about the next elements of the algorithm. By themselves, the full bed value and the empty bed value are a pretty good algorithm for detecting when you're in bed and when you're out of bed. The problem, though, that I would have sometimes, and we haven't talked about the auto-calibration, but sometimes the auto-calibration might make a mistake, or sometimes you would get into bed and it would just take a while before the pressure value signal would actually cross over the full bed value. And that's just because the device sometimes can take a little bit of pressure, prolonged pressure, before it drops low enough. So I added in what is called the dynamic full bed threshold. I have to move out of the way so you can see it. And I'm going to turn this on. And what this does is now this is looking for really sharp spikes downward. And so if I put my foot on and I get this really big sharp spike downward, but I didn't go all the way to the full bed threshold. Now I know something just very quickly got into bed. So I added what is this dynamic threshold, and instead of having to go all the way to this yellow full bed, as long as you go below this teal, this dynamic threshold, for at least, again, base still has this requirement having to be below it for at least a second, then it'll actually trigger based off of that really sharp change. And if I take my foot off, because we're only talking right now about the full bed threshold, if I go above this empty bed value, then I will go back to being clear. And I'm going to scroll down here because there are some things you can manipulate with this. I defaultly have this turned on. I thought it was really nice to have a really snappy, I'm in bed, and you want the device to trigger that you're in bed. So it's defaultly really sensitive. So this is the full bed detection sensitivity. It is a full value here. And some people, if you have issues, and I will talk about it later as well, if you have a dog, a big enough dog, or if you're constantly throwing things on and off your bed, then maybe you want to reduce this down So that way, and you can see now, if I were to take another one of those big push downs, but I didn't quite make it. Oh, I did make it. I made it too far. Maybe I didn't. I didn't make it too far because I didn't stay below it for more than 1 second. So now there was a big sharp dive downwards, but I didn't go below that threshold, and maybe that's the dog getting on and off. So you can also turn it off completely if you take it down to 0, and now it does turn it into this, as we were talking about before, this full bed value. It has to go below that before it would trigger that you were in bed. Okay, I'm going to put that back to the default value, and we'll talk about the next threshold. The dynamic empty bed threshold, which is this next one here, I'm going to probably have to roll my chair out of the way so you can read it, is very similar to the full bed threshold, except where the full bed threshold increased the rate of getting a detection, or so that you're in bed. The dynamic empty bed threshold increases the speed at which you will get a clear signal that comes out of it. Now, that said, and I'm going to turn this on, and ignoring this part over here where I was doing some testing, it is the exact same value as the empty bed value, because defaultly the empty bed detection sensitivity is set to 0. So, and there's a reason for that, and let's talk a little about it. So I'm going to turn this up so I can show you why this is defaultly set to 0, and then why you would turn this on at all, because it is defaultly off. So if I put both my feet on the sensor here, and now you'll see both the dynamic thresholds moving down because they are trying to catch up with the pressure voltage signal. And it is really common, if you are sleeping, for you to move around a little bit. So what that might look like is, I'm gonna lift off one foot, see if I can get it to go a bit higher. So here, I've just shifted a little bit in bed, and then I'll put my other foot back down, but this is just me kind of maybe rolling around and moving back. Well, with this sensitivity turned really high, now the pressure voltage only needs to go above this purple dynamic line before it triggers to be clear. And I didn't get out of bed, I just moved around a bunch. So I typically leave this off or really low, because having it very high will increase the chances that you will get a false positive. So why is it there at all? And the reason that it's here at all, and I'm going to move this down to explain it, is sometimes, so I'm going to put this maybe to, so it's more visible, to maybe like a 3. Sometimes after being compressed all night, under certain bed setups, SlumberTek can be a little slow to recover. And what that looks like is, instead of a nice, clear, straight kind of up that goes very high, you kind of get a very slow, muted one. So I'm going to see if I can do it here. So you get a nice, clear start, and then it kind of slows down a little bit, and then it slowly kind of comes up until, you know, it'll reach this mark over here. It's not super common. It is very dependent on bed setups. It has to do with just how compressed the device gets under certain bed setups. And this is the only reason that I ever suggest that people turn this on, because most of the time I have it set to 0, so you don't get some of these false outings and have it trigger something in your home that you didn't mean to trigger. Let's talk about calibration and auto-calibration. So you would want to do a calibration anytime that you have moved your SlumberTek into a different bed, or you've just set up your SlumberTek for the first time. And luckily there's some explanation here where you're going to turn the calibration on. It's going to collapse all the elements that we've been talking about, actually all into one point. Then I'm going to put my feet on my device down here. You would get into your bed on top of your SlumberTek. You would wait at least 30 seconds or so for the signal to kind of level out. I'm not going to wait that long because this is just for a demonstration. And then you would get off of your bed, and your signal will come back up. And then you would turn your calibration off. And what it's going to do is it's going to estimate new thresholds based off of, right, the full bed value and the empty bed value. It's going to estimate those based off of the maximum values and the minimum values that it saw from your calibration. Okay, again, you would only need to do this if you moved your device or this is the first time you've set this up, because what should happen next is auto-calibration will take over, and I'll talk about that. Auto-calibration, I think, is one of the most important parts to SlumberTek, and it is what is going to keep your SlumberTek hopefully very accurate day after day, week after week, month after month, and especially through changes of temperature throughout the summer and winter, and then also even changes in yourself over time. So the way that the auto calibration works and is defaultly set on, I've actually disabled it while I was showing you some of the previous stuff so that way it wouldn't shift around. I have a special device here, which is, instead of calibrating, typically your device is going to collect 24 hours worth of data. It's going to take a reading every 30 minutes, and then it's going to use that data to figure out the maximum and minimum values during the last 24 hours, which hopefully you slept within the last 24 hours. I'll talk about later. If you haven't, that should be okay. It'll reject any changes if that happens, if you don't use your bed. So, but this one is actually my particular device that I'm playing with here. Instead of every 8 hours or every hour, it's actually going to take a reading very quickly. So it takes a reading, I think, every like 3 to 6 seconds. And that's only for debugging purposes only. So what's going to happen here is I'm going to put a step on here. I'm intentionally going to put this a lighter step because I want you to see how the calibration changes. So I'm going to be on, I'm going to let a couple of hours worth of data get picked up here. And so that way it's got some high pressure voltage data and it's got some low pressure voltage data. And then it's going to take those and it's going to decide how to manipulate the full bed threshold and empty bed threshold. Yep, so it did what I expected it to do, and now it has tried to calibrate to this new single foot pressure voltage that I've put here. So now, compared to the 2 foot one that I had previously, this is now a much higher value. So I guess the question might be, what would you need to do or manipulate? Because if this happens automatically, why would you need to change anything? So the rest of this is going to be talking about some of the manipulations you can do. The one I will finish off this section with is you can move this up so that auto calibration only happens every 8 hours, every 12 hours, every 24 hours. It'll always use 24 hours worth of data because I assume you've slept with at least once during the last 24 hours. But it's just how often that it might try to make a change to your calibration. I find that typically between 8 and 12 hours is best. Let's talk about now some of the things you might want to manipulate for your auto calibration. Maybe because there's something interesting happening with your bed setup, or maybe you just want to play around with the auto calibration a bit. So the most important one here, and I'm going to have to turn it on. I think you should be able to read this because I think I'm far enough to the side, but this is the midpoint estimate. So when a calibration is done, auto or manual, it will take those maximum values of pressure voltage and those minimum values of pressure voltage, and it will estimate a midpoint. And in this particular case, actually, I defaultly say that the midpoint, which would be 50%, I actually tell the system that it should be 30%. And I have just found historically that moving that midpoint down, the percentage of that gap between the maximum and minimum, moving it down to like 30% and having the thresholds based around this 30%, it seems to be just a place that keeps accuracy pretty high. I find that if I move this too far up, that I can get a lower accuracy. So, but you can adjust it if there's something going on or you just want to play with it. The other important aspects that you can manipulate directly is the empty bed threshold. So yes, it calculated an empty bed threshold from the calibration, but you can actually manipulate that further away. So if you move this up to, let's not go too crazy here, so like 70%, you will see this will jump upwards. The reason you might want to do something like this is maybe you're having an issue with false positives for when you're moving around at night. The noise that you have from moving around is causing big spikes upwards, and maybe you might want to move this up. This is actually not uncommon, and I will probably talk about it later as well, to solve a lot of false outings that trigger and then aren't you actually leaving bed, but they're you moving around in bed. But defaultly it's set to 30. You can also adjust, and the percentage here is then away from kind of the midline to that maximum pressure value. These are all calculated when an auto calibration happens, and they're all based off percentages of the maximum minimum value. So if you are in bed one night and then for whatever reason you let somebody else sleep in your bed and they have a very different weight profile than you do, then it will begin to calibrate to that new person that's in there, but it will keep the same percentage. So it will always be 30% of the midpoint. The midpoint will always be 30% from the minimum value of the pressure voltage and the maximum value of the pressure voltage. And the empty bed threshold will always be 30% of that distance from that midpoint to the maximum value. Or for the bottom here, the full bed threshold, same thing. You will always be 30% from the midpoint to that minimum value. And actually, I haven't figured out a reason why you would want to manipulate the full bed threshold downwards. I haven't run into a situation where that has been necessary, but I like to allow people to explore. So that both of those exist to manipulate. There's one other slider here, which is kind of important. We've kind of talked about most of the rest of these, which is the auto calibration trigger sensitivity. And this has to do with, and very relevant for people who have dogs and other items that get put on their bed. So one of the things that people have explored in the past, which I kind of liked, but there's a reason it didn't end up working out, is some people have actually removed these full bed detections down to 0, and then they've actually pulled in their thresholds really close to this midpoint. So now you have a really tight threshold that you need to, or double threshold that you need to cross and come back. Well, one of the things that can be difficult about that, if you would like to go that route, is the way that I've set up how sensitive the auto calibration is. And what happens here is the gap between your full bed value and your empty bed value is a calculated number, and this is then a percentage of that number that the pressure voltage needs to travel for it to consider recalibrating. So what this might mean in this particular case is, right, if you have a really small gap and you have a small step on it, right, this is probably going to try to recalibrate to this small, and maybe in this particular case, this is the dog getting on the bed, but not you getting on the bed. And we'll see what happens. It'll be a little bit before it tries to recalibrate. But if you wanted to reject this you didn't want it to auto-calibrate to this gap because this is just the way you've set up your device, then you would actually want to increase this to 150 or 200% of that gap between the full bed value and the empty bed value. This is a very nuanced thing to manipulate, but some people see, because now it's trying to calibrate to the dog that got on the bed, and it's not calibrated to a person getting on the bed, which is a much bigger signal. And it also has shrunk this gap because it's all based on percentages. So those are all the manipulations that you can use with the calibration. I left them all in here because I think they could be interesting for people to play with if they have unique bed setups. But I wouldn't generally suggest manipulating them unless there is a problem that you are having, several of which I will get into in the next chapter sections. I wanted to point out one other important aspect of the algorithm, and actually it's here in the UI section, which is this slider called pressure voltage filter. It's unusual, but sometimes people have very noisy signal, and I'm trying to recreate it here by pressing on and off very quickly. And for whatever reason, they have a lot of spiky noise in their voltage signal, and it can impact your accuracy. My suggestion here is you can move this up to either 2 or 3, and basically what that does is if I repeat that same action now, it's not going to be as bad. It helps to really shrink some of the noise you can get down to something smaller. It does add a little bit of delay into the signal, but it is worth it if you can get the accuracy back up. So if you're having trouble with really noisy data, and sometimes I've seen it just from just electrical sockets, sometimes they're just particularly noisy, then it can be worth increasing this filtering so that way the signal's a little bit slower, but a lot cleaner. I sometimes hear about people who do manual calibrations that are very accurate and they work when they get into bed for that night, but then the next day that calibration doesn't quite work and they recalibrate again, and they kind of get into this cycle of it works for a little bit and then it doesn't. Basically what happens is if you calibrate, so you turn this on and then you get into bed, into your SlumberTek, and it's going to now calculate some new threshold values for when you're in and out of bed, right? So I'm not going to do the full 30 seconds here, but I am going to pretend I got into bed here. I have a device under my feet here, and I'm going to turn off my calibration, and then it's going to estimate new threshold values, which means that the pressure voltage needs to cross these values before it detects whether or not you're in and out of bed. But this 30 seconds of data or 10 seconds of data I did here isn't really enough for the device to get an accurate reading of what these thresholds should really be. So make sure that your auto calibration is turned on. So make sure your auto calibration isn't 0. So make sure it's probably at least 8 or 12 is usually what I try to tell people. And make sure that your manual calibration has had the 24 hours it needs to start doing the automatic calibration, because the automatic calibration is going to have that 24 hours worth of data, which is going to be really helpful for better estimating these thresholds, better than the 30 seconds of data you gave it. This also can be an issue too if you've just put it underneath your bed or there has been some shifting around of the device itself. Sometimes it takes a little bit for the device to kind of settle in, and it might be the calibration you do for the first couple of nights might end up shifting over time. But that is, again, why I think you should have your auto calibration up and working. And if your auto calibration isn't quite working, then that's a good time to message me or to watch the algorithm section of this video if you're interested in learning more about what you can manipulate with your auto calibration. One of the most common things I hear from people about their SlumberTeks is that they're really snappy to get into bed, so they detect very quickly, but sometimes people have issues with how quickly that your SlumberTek detects when you're out of bed. And sometimes that can be a couple of seconds, and sometimes that can be a couple of minutes or longer. And those are actually two different problems, and we're going to talk about different ways that you can improve your SlumberTek's responsiveness of you getting out of bed. Now, the first one that you can come in and check very quickly is your transition to off delay. Now, this is the amount of time that your pressure voltage here needs to be above your empty bed value before it'll even send a clear signal to your Home Assistant. The default value I think is about 3. For examples in this video, I've put it down to 1, but it can be all the way up to 20. Maybe you manipulated it and didn't realize it. Go in and check that, reduce it down if you want it to be a much snappier out of bed, and then boom, it sends a signal to your Home Assistant that you're clear. The other really common thing that happens, and I've mentioned this a couple of times, is if you have a slat bed and you haven't put a piece of cardboard, like the packaging that SlumberTek comes in, or a piece of plastic or piece of plywood underneath your SlumberTek, then sometimes your signal is just not as strong. And what that might look like is, and I have a device underneath my feet here, and I'm going to step on it and explain this a bit more, right? All the gaps between your slats are areas at which your SlumberTek isn't getting any signal from because there's nothing squishing it. It's just kind of sitting in between your slats. So what that might look like is if you were in bed and you got out of bed, and this is, I'm going to try to get this as close as possible, right? You have initially this really sharp up, which is you getting out of bed, but then your signal kind of trails off and you haven't triggered to be out of bed yet because you haven't gone above this empty bed threshold line, but your device kind of slowly wiggles its way over time, you know, and this could be over 30 seconds, this could be over a minute, this could be over 5 minutes. In some worst cases, it can be 10 minutes or more, right? And eventually it kind of slowly, gradually goes above this line. And once it goes above that line and the amount of time for the transition has passed, then it'll finally trigger to on. But maybe you really want it to be snappy. So if you have slats, then you're really going to want to put something underneath it. Again, I'm trying to fix this in future versions of SlumberTek. Now, if you have a box spring, or you did put something underneath your SlumberTek and this is still happening, not super uncommon. There are some things that we can change in the way your auto-calibration picks these full and empty bed thresholds. So that way this is less of an issue. So I'm not going to go into details of everything here. That is what I talk about in the algorithm section if you didn't watch it. So I'm just going to show you the sliders that you might want to manipulate. And the first one here is defaultly this empty bed detection sensitivity is usually 0. And I'm going to suggest you move it up maybe to 2 or 3. And that is going to help kind of grab sometimes when you initially get out of bed, if it doesn't make it all the way to your empty bed threshold, this is going to help trigger earlier that you're getting out of bed. The other thing you can do is you can adjust down this empty bed threshold adjuster here. I'm just going to move it down so you can kind of see that it just moves this empty bed threshold down. So that way it's a little easier again to trigger as you get out of bed. One of the other things you can do as well is you can also shift both of these threshold lines down a little bit, if that is something. So now everything's been shifted down a bit, and if I were to redo this test again, it might grab me initially right as this transition happens. There's a lot of sliders here that you can manipulate to kind of produce the same result, and hopefully some combination or one or two of those things really helps to reduce how long it takes for you to get that clear signal when you get out of bed. There's a lot of things you can manipulate here. One of the other common problems I hear from people is if they are in bed during the night and they move around a bit, they will get what I refer to as kind of false positives or false outings that triggers an automation that they don't want while they're in the middle of sleeping. So what this might look like typically is, so here I have a device under my feet here, and this is my pressure voltage, and I've just stepped on my device and my pressure's gone down. So this is you're in bed, you're sleeping, your device has detected you, and for a second or so, you move around and then you shift back, right? So you lift a little bit or you rolled and then you rolled back. But you have this clear state in your home assistant that may have triggered something. You didn't want that to happen. So here are a couple of ways that you can fix this. The easiest way to fix this, especially if these are really short and quick, is to just move up your transition to off delay to a little bit longer. So I had the default is 3, I had it down at 1 there. If you move it up to like 7 or 8 or 9 or something like that, then if I try to replicate this same thing, what's going to happen is it's going to go up, and then I'm going to lay back down again. And this is pretty much the same motion, but it didn't trigger an off or a clear because the blue line wasn't above this empty bed value for more than 8 seconds. And that is why it didn't trigger off. This line needs to be above, this blue line needs to be above the red line for more than 8 seconds. This is a really simple way to fix this problem. If, though, you are using your device as a nightlight activator, if you get up in the middle of the night, either under the bed lighting or your bathroom lighting, that's probably not going to work super well for you. And here's a couple other things you can manipulate. So if you really want this to be typically snappy, so that way when you get out of bed it works, what you might need to move, and again, these are all settings that are explained in full detail in the algorithm section. But here, if you just want to jump to a couple of these things to try to reduce this chance of getting these false outings, if you come to the empty bed threshold adjuster here, if you just make this a bit higher, so if you move it up to like 50 or something like that, then you're less likely to get these, have these trigger to come out because you're going to be higher. This upper red line is going to be higher. Make sure your empty bed detection sensitivity is 0. out, and which is the default, is turned off, so that way you don't trigger on the way up, which it would, again, that would be looking for sharp changes. And so that way this doesn't trigger off of a sharp change. And the other way you can manipulate this as well is if you go to the midpoint adjuster up here, you can also move both the lower full bed value and the empty bed value up as well. There's a lot of things you can manipulate here to try to fix this problem. Again, then I would only manipulate these if you really want to keep your bed very snappy when you get out. You really want a short delay, but you really don't want your night motions to be triggering, your kind of clear signals out of your bed. So this is an interesting problem that I hear a decent amount actually, which is somebody will have a pet, either a heavy enough dog or a heavy enough cat, that will jump on their bed, will lay down roughly where their SlumberTek is, and then their device will trigger during the middle of the day. That will trigger some automation because their pet was on their bed. Typically what this might look like, right? So this is the pressure voltage here, and if I press on my device underneath my foot here, that it is kind of a small signal. It doesn't go down as deep as, so this is my pretend I'm in bed signal, right? And this is my I'm a large dog or cat. And I don't go that far down, but it's far enough that I end up triggering a detection signal. And then later, after the animals had a nice nap, it will come off the bed, and then you'll end up with this clear signal. So there is actually a really simple way to fix this problem if you're having this issue. That is to come down to the full bed detection sensitivity, and it is defaultly a maximum value, which is 9, which typically what that does is it makes your bed really sensitive to people getting, or animals apparently, getting into it. So if you move this down to maybe like 4 or 5, and then if I do that same thing again, and hopefully we don't end up triggering, I can pretend to be an animal, roughly the same weight again, and see if it'll trigger it. So it should not, because as it goes down, it won't go down all the way. Again, we're trying to match this previous animal in bed signal. And here, so at this point, previously it triggered while the animal was in bed, and here now my animal signal is not triggering because we've reduced this setting. So, and now if I come back up again, we never triggered. So that's a really easy way to fix it, moving this down. This can slow down ever so slightly you getting into bed, but you getting into bed is usually a very big signal, and your pets are not as big of a signal. Alternatively, one of the other things you can do is you can adjust your auto-calibration midpoint slider down to a bit further. What that's going to do is that's just going to move this empty bed threshold and this full bed threshold down a bit further. And again, now these values, which are your thresholds for making decisions of detection and clear, are just further away from where your animal was. And that will also solve the problem as well. So either reducing your full bed detection sensitivity or dropping down your midpoint adjuster a little bit are both ways that I have found to successfully get rid of the animal in your bed triggering your SlumberTek. I hope something in this video was what you needed in order to solve whatever SlumberTek problem you have, or maybe you just want to learn more about the algorithm or a lot of these sliders and what they actually do and affect how your SlumberTek works. The last thing I will say real fast, if you didn't pick it up while watching the rest of this video, is sometimes when you change some of these sliders, you can solve one problem and cause another one. So, right, for something like, for example, the empty bed detection sensitivity, if you turn that on, well, now your bed will trigger more quickly when you get out of bed. However, you now have also slightly increased the chance that you might get the false positive outings, right? The time at which you're actually sleeping and maybe you roll around a bit and there was enough of a spike where the SlumberTek actually thought that you got out of bed because it's trying to be more sensitive to you getting out of bed. So every slider has a bit of an impact on kind of your accuracy. I am always working on how to change the algorithm and how to change the hardware so that way there is kind of one setting and I won't have to need all these different adjustments in the future, that you'll just be able to, put it under your bed and plug it in and it'll just work regardless of whether or not you have slats or a box spring or a soft mattress or a hard mattress or whatever else that you're using. If you continue to have any more problems though, and nothing in this video solved them, then you can either reach out at hello@asc.com, or you can go to asc.com and go to the contact us section and send a message that way. Okay, I hope this was helpful. Bye.